Welcome back, kiddos. Today we're going to be talking about percent yield in our final video lesson for this unit. So what have we learned so far? Well, we learned how to use stoichiometry, which is basically just dimensional analysis to convert from an amount of a starting substance into an amount of another substance using a balanced chemical equation. We also learned how to do that same kind of thing, dimensional analysis, using the balanced chemical equation to determine the change in heat, whether heat was absorbed or released, or maybe we know how much heat was absorbed or released, and then we wanted to convert between kilojoules and, from kilojoules to an amount of a starting substance, or maybe even an amount of a product. We also learned last time how what a limiting reactant was, and how we determine which of our reactants is going to limit how much of the product we can make. Remember that whole concept where if we had a bunch of graham crackers, a bunch of chocolate, but only 3 marshmallows, we could only make 3 s'mores. So that's what we learned this last time. Today, some objectives for you today. How do we determine the efficiency of a reaction? What is theoretical yield? What is actual yield? And of course, how do we calculate the theoretical yield? You'll find that we kind of already have been calculating the theoretical yield. Can't talk today. So what is efficiency? Well, efficiency is the quality of being efficient, and it's the accomplishment of or ability to accomplish a job with the minimum expenditure of time and effort. And it's really important in industry. And so these companies, they're in the business of making money. They want to make as much of their product that they possibly can for as little cost, meaning with as little waste as possible. So a great example of one of these types of industries is the pharmaceutical industry, where they are using chemical reactions to make their drugs. And so they want to make sure that they are able to make as much of the drug as they possibly can for as little cost. So they use the efficiency of a reaction to really measure how good their processes are for making these drugs. So how do we calculate the efficiency of a reaction? Well, let's look at an example really quickly. So Janie does a chemical reaction, and she figures out that with 5 grams of mercury, she should have been able to produce 5.40 grams of mercury 2 oxide. But when she actually did the lab and she measured how much product she actually made, she only had 3. So how would we measure how efficient that reaction was, or her process for doing that reaction? Well, let's look at another example. Okay, so you might remember these. I'm still in awe personally, but we're going to use this yet again. Alright, so I'm still in awe by what we saw in the s'mores video. But so what I decided to do was make these cookies. I go to the store, I get all the stuff, get all the ingredients. When I get home, somehow I didn't make it home with one of the rolls of cookie dough. So I decided to just go with it, right? And so I count the number of cookies that I end up with, and I end up with 12. How do I measure my efficiency? How good of a baker I am, really? We have to look at 3 things. The first thing we have to look at is how many cookies I should have been able to make. So I had enough of everything except for the cookie dough. So I only had 1 roll. So I want to know how many cookies I should have been able to make with that. Well, I'm going to cookies, getting rid of rolls of cookie dough. Well, according to this balanced equation, I could have made 32 cookies with 2 rolls. Okay, so the rolls will cancel and I'll be left with the number of cookies that I should have been able to make. Well, 32 divided by 2 gives me 16. How many cookies did I actually make? Well, I told you I made 12 cookies. What grade would you give me as a baker? So if you had to give me a grade like I give you a grade on the quiz, on a quiz, what would you give me? Well, I only made 12 out of 16 cookies. So that would be 3/4 or 75%. So my efficiency would be 75%. I'm only 75% efficient. I made 75% of the amount of cookies I should have been able to make. So now let's see how that fits into an actual chemical reaction. In fact, we're going to revisit Janie's reaction. So she calculated that she should have gotten out 5.40 grams of the mercury 2 oxide. And when she did the lab, she found that she actually only got out 3 grams of the mercury 2 oxide. So, how would we measure her efficiency? What grade would we give her? Well, we have to look at those 3 things yet again. In theory, how much should she have made? How much did she make? And then let's give her a grade. So in theory, she should have made, according to her stoichiometry, 5.40 grams of HGO. In actuality, however, she actually only made 3. HGO. So what would her grade be? What kind of grade would we give her? Well, she actually made 3 out of the 5.4. Okay, so she made 3 out of 5.40 possible grams. So that would give us 0.555 forever, which gives us, when we change it to a decimal, to a percentage, 55.6. Let's write this up here. 55.6%. So that would be her grade. Well, that's efficiency, guys. That it would be how efficient that reaction is. It only produced 55.6% of what it should have produced. So, like I said, what grade did we give her? 55.6. That's efficiency. But we don't actually call it that. It really has a different name in chemistry. It's called percent yield. So what is percent yield? Well, it's equal to the actual yield, how much of a product that we actually made in the lab, divided by theoretical yield, how much of that same product we were supposed to be able to make. And we multiply that by 100 to change it to a percentage, because it needs to be in the form of a percent. So this is how we measure efficiency, with percent yield. And yield refers to a product, so yields are always products. You'll never put an amount of a reactant in this calculation. Well, what is theoretical yield? Well, we said it's the amount we're supposed to be able to make. It's calculated using stoichiometry. So we've done this a lot already. In fact, every single stoichiometry problem we have done so far has been theoretical yield. Okay? So every single problem we've done, the answer we got was theoretical. All right? How much we should get according to our calculations, according to the balanced equation, according to how much stuff we're given to work with. The actual yield is the amount of product that was actually made. Okay? This is measured. Theoretical is calculated. Actual is measured. Okay? It's how much you actually get when you do it. Alright, so that's really all there is for today, guys. Make sure you know how we determine the efficiency of a reaction, what theoretical yield is, what actual yield is, and what percent yield is. And we will do lots more of these in class. So thanks for watching, and we'll see you next time.